quantum computer, it's basically a completely new type of computer. You can think of it, it's a new species of a computer. And the reason why it's called quantum computing is because it uses quantum physics. So quantum physics describes how the world works at the most fundamental level, the level of atoms and subatomic particles such as electrons. And there's a lot of strange behavior in quantum physics, and a quantum computer uses that behavior, it harnesses it to actually compute and solve problems.
Hey friends, welcome to the Tech Unlock podcast. I'm so glad you're here. This show aims to demystify tech careers and diversify the tech industry by giving you the keys to unlock your successful tech careers. I'm your host, Grace McJones. Let's jump right in. I am thrilled to have my guest with me on the show. I've been waiting for this episode for a long time because it's a topic that it's really exciting and it's an emerging technology, and I'm glad that we have an expert with us today. Welcome to the show, Jessica Pointing. How are you?
Thank you for having me. I'm doing well. How about you?
I'm doing good. I know it's been a while. We've been scheduling, trying to figure things, and I'm glad that we finally have the space to talk about quantum computing. And just so that people get a background about you, you are a quantum computing researcher. Like, you've studied at MIT, Stanford, Harvard. How has that journey been, and what has been the most challenging part of all of that?
Oh, yeah. So I think the most challenging part of going through all these universities was actually when I was at MIT my second year, my sophomore year. Basically, MIT costs like about $60,000 a year at least. And my parents had paid the first year, but by the second year, they couldn't pay anymore. So I had to end up like finding the finances to pay. And I had at least 3 jobs, and I was applying for all of these scholarships. And it came to the spring of my sophomore year when I still had $20,000 left I owed MIT. And in fact, they were sending me like emails like they were actually not going to let me be a student anymore and kind of not let my grades count and all of this stuff. So I was very stressed, obviously. And I'm a Christian, so I prayed to God. I was like, God, please help me with this. And I remember one week, it was probably a Monday or something, I got an email like, congratulations, you got this $5,000 scholarship. And I was like, oh, great, like $15,000 to go. And then actually a couple of days later, I got another email like, oh, congratulations, you got this $10,000 scholarship. And then a couple of days later, I got another scholarship. So by the end of the week, I actually had the $20,000 paid, which was just amazing. And I thank God for that. And it did make me realize that it wasn't a really sustainable solution. I still had 2 years of college left. So I think this is kind of where I just went into brainstorm mode. It's like, okay, here's a problem, and how can we fix this? So I think one solution was maybe I could go work at a company, but there was restrictions on that because I was an international student, or maybe I could just transfer to another university. So that's actually what I ended up doing. I ended up transferring to Harvard, and they basically gave me almost a free ride. So in essence, I saved more than $120,000 by doing that. And yeah, I think the lesson I learned there is when you're encountering something difficult, kind of try not get stuck on the same like path or solution. Sometimes that happens with code, maybe you have a bug and you kind of keep trying the same thing over and over again, but kind of just think radically different. Like, okay, let's just brainstorm here. Is there something completely different I could do? And it wasn't so common for people to transfer from MIT. So it wasn't a common thing to do, but I just thought, okay, let's just think out of the box. And it was one of the best things that happened. So I'm glad. Yeah.
That is wild. I mean, and the reason why I started with that story is because you are an award-winning researcher. Like, you've won so many awards, and like you've given a lot of talks. Like, I research your stuff on YouTube. I'm like, oh my gosh, like this person is incredible. But you don't see that part of the struggle in a sense. And so sometimes so you can look at someone's life and like, oh, look at all the amazing things they've accomplished, but it's never that easy. So thank you for sharing that story with us. And now kind of like going back in time and talking about how in the world you got into quantum computing. Can you kind of tell us like what got you interested, right? Did you grow up with parents who were like super into tech? Did you know this is what you wanted to do as a career? Like, how, paint that picture for us.
Oh, yeah. So it was actually about 10 years ago, and I was a young girl in middle school, and my school got invited to this technology workshop at the local offices, the Microsoft offices. And actually, so I grew up in a town called Reading in England. And I remember walking into this room, and they just had this cool setup. They had all these experiments, and they had like this touch screen with these fish swimming across. And, this was before the iPad. So it felt like very like technology in the future. So, and I remember there was this guy, and I actually found out later his name was called Chris Bishop, and he was giving a talk on computers of the future. And so he was talking about these futuristic ideas for new computers, and one of them was quantum computing. And at that time, I didn't quite make the connection to quantum computing, but he actually did talk about quantum physics, and I vividly remember him like describing superposition and all these things with like coins. And I just remember being completely mind blown, like, wow, this is so fascinating. This isn't something I've heard in school. And I think that was sort of the spark for me. I remember after that, I bought a book, and I actually have it here, called 50 Physics Ideas You Really Need to Know,
Nice.
by Joanne Baker. And, I just read through all these like fascinating like physics phenomena. And it wasn't until I got to college, so I kind of knew I wanted to study physics at that point. And then when I got to college, I was sitting in a dining hall, and my friend came up and was like, oh, there's this quantum computing course, you might be interested in it. And, I sort of heard a bit about it. So I thought, okay, why not? I'll take it. And I remember it was the worst time to take the course because I joined several weeks late because I heard about it late. And so I was up at like 3 a.m. studying for the tests the couple of next days because I had to catch up. And yeah, it was just like awful situation. But I remember really enjoying like learning about like quantum computing. And I remember just being like, oh, wow, this is really cool. So that kind of was like a switch, like, oh, maybe this is something I should do. And then after I took the course, I ended up doing research with the professor of the course. So I just asked him, can I do research? And he agreed. And then after doing research for a few years, I decided to do the PhD. So now I'm doing my PhD in quantum computing.
What a journey. Like, and I love that, you mentioned, school in a sense of like being exposed to something so new and something so different. And that's what, like, I hope this podcast, where people are just like, oh, like I really, either I'm new to technology or I'm interested in technology, can just say like, oh yeah, I heard this episode. And it's just kind of like made me even more interested in like learning more about this particular thing. So thank you so much for sharing that. So when it comes to, quantum computing, it's such a sometimes daunting phrase, because for some people it's just like, where do you even begin, right? So for those who might have like never even heard the term quantum computing, or are super new to the space, what is quantum computing and why is this so important right now?
Yeah, quantum computer, it's basically a completely new type of computer. You can think of it, it's a new species of a computer. And the reason why it's called quantum computing is because it uses quantum physics. So quantum physics describes how the world works at the most fundamental level, the level of atoms and subatomic particles such as electrons. And there's a lot of strange behavior in quantum physics, and a quantum computer uses that behavior, it harnesses it to actually compute and solve problems. And the thing is, the reason it's exciting is because there are problems we theoretically know could be solved so much more faster on a quantum computer compared to a normal computer. So there are literally problems that we think could take billions of years to solve on our normal computers, let's say the world's best supercomputer. But on a quantum computer, it could take just seconds. So as you can see, that's a huge difference. So we can tap into the unsolved problems, things that are practically impossible to solve could be solved on quantum computers. And that's why it's exciting.
And, in one of your talks, you talk about the difference between a quantum computer and a classic computer. And that was very fascinating to me because it's like, oh yeah, like for right now, like all we're used to is just our classical computers. And so why, I think you just mentioned a bit, like, why is it that a quantum computer can solve much more complex problems than a classic computer?
Yeah, it's a good question. So I actually use a little illustration. So here I have a donut.
Okay.
And if you're just listening on audio, you can imagine me holding a donut, a big like pillow-sized donut. So the classical computer, it processes and stores information in bits, zeros and ones. So you can think of this donut like a bit. So let's say 1 is the frosted side and 0 is the plain side. Well, in a quantum computer, it's similar. It still has bits, but they're actually called quantum bits, also known as qubits. So a qubit can be 1 and it can be 0. But as I said before, it has quantum behavior. So it can also be a superposition of 0 and 1. And I think of a superposition like a spinning donut. So now this donut is spinning. And I ask you, is it 0, 1? Well, you say it's a combination of 0 and 1. And that's sort of what the superposition is like. Of course, it's an analogy. So, but, and then what the quantum computer does is it uses this new behavior. It's like we have these new tools, and then we can use that to solve problems in new ways that could potentially be more efficient.
Wow, that's super cool. I love that illustration. And so in order to kind of like connect the dots, what are some problems or some difficult or complex problems that we can use a quantum computer to solve?
Yeah, so I have another illustration actually. So let's say
I love this. Break it down for all of us because I'm learning too. This is exciting.
Yeah. So let's say we have a bag with 100 balls. So there's 100 balls in here. And let's say you have a classical computer and you want to find the ball. Let's say each ball is numbered from 1 to 100 and you want to find the ball number 3. So essentially, because this is kind of, there's no structure to these balls. So you'd have to, go inside, pick up a ball, check whether it's the number 3, and then, go to the next one until you find the number 3. And that's essentially what a classical computer does when it comes to this type of problem. But on a quantum computer, so if we had 100 balls, it would take up to 100 tries, right? Because you could get to the ball number 3 on the last try. But on a quantum computer, imagine all these balls are in superposition. You could actually find the ball number 3 in just 8 tries. So even though there's no structure and we have 100 balls, you could guarantee up to 8 tries. So as you can see, that's an example of a problem. And you're thinking, okay, what's that connected to? Well, imagine if you had a database with n entries and there's, it's unstructured. You could, classically, it would take up to n tries to find a particular entry. But on the quantum computer, it actually takes up to square root of n tries. So that's one example. And this is using a quantum algorithm. So basically, a quantum algorithm is a set of instructions that you give to the quantum computer to solve a problem. So people come up and invent quantum algorithms. So there's a guy called Grover who came up with this algorithm to do that, and it's called Grover's search. So that's one example of a problem. And then I should say a second example is actually it's basically simulating nature, understanding the world around us, because everything around us, as you know, maybe is made up of atoms. And they all follow the laws of quantum physics. So if we had a quantum computer, we could basically model what things around us are doing. And this could be incredibly useful. So for example, in medicine, you want to design new drugs that could, interact with the molecules in your body to help cure some problem. And with a quantum computer, you could maybe model and design new drugs. Also, material science, you want to design new types of materials that could be used to make your laptop or your phone better. And again, with a quantum computer, you could simulate, model, and potentially design new types of materials. So as you can see, there's quite some exciting applications.
So, while you're giving that description, I don't know if you've ever watched the show Devs on Hulu.
Yes.
You have? Okay. And like when you said like a simulation, I'm just like, oh my gosh, like that's kind of like what the show is about. And if you haven't watched the show, I would highly recommend it. But that, prompts me to like my next question, like what are some cons of quantum computing, like in terms of like, are there ways that it could be used in a harmful way? And, what are ways we can kind of like mitigate that?
Yeah, it's a really good question. So one of the biggest concerns, I would say, is actually one of the reasons why quantum computing became popular, was that there's this guy called Peter Shor, and he's a professor at MIT, and he came up with a quantum algorithm. It's called Shor's algorithm, surprisingly, and he actually found that you could basically break some of the encryption methods that we have today, such as RSA. So basically, your data on the internet is secure because of encryption.
Yeah.
But if you had a quantum computer that was powerful enough, you could essentially break it. And this is a big concern. Now, I should say that in order to do this, you would need a quantum computer with millions of, qubits. But at the moment, we have like around 53 qubits. So you can see we're far away from that, but we are scaling. And so it's definitely possible, like in several years, that we'll get to this point. So this is probably one of the biggest concerns. And what we can do to mitigate this, well, people are working on mitigating this because it is a big problem. So one thing is there is a field called post-quantum cryptography. So the idea is let's actually create new encryption methods that could be safe against a quantum computer. So people are actively working on this. But the thing is, there are, I think it was estimated there's like more than 20 billion like devices out there that you would need to replace, all of these encryption systems. So it's, that could take a while to do. So it is something we do need to think about now before we have that quantum computer that could do that.
Gotcha. And just for those who might not know the term encryption, what does that mean? Let's break it down for them.
Oh yeah. So basically, you have your, so let's say you have your credit card number on the internet, and when you're on the internet, you don't want other people to be able to see that credit card number. So we want to kind of jumble it up so that someone else couldn't recognize what your credit card number is. And the way it's jumbled up is actually by using something in mathematics. Is you have this really large number, and you basically have this really large number, and let's say that we want to then unjumble it so that we can read what your credit card number is. Then we can find basically the prime factors of this number. But this is a problem that is really hard to do on a classical computer, and that's why no one can find those two numbers to unjumble your number, because it's practically, it would take a really long time, like billions of years to just do that. And so basically that's where a quantum computer comes in, is that it can actually find those prime factors of a really large number much more efficiently than a normal computer. And that's why it can actually be able to basically unjumble and find out what your credit card information is. But as long as no one can find out those two numbers, then your credit card information is still jumbled. So I don't know if that explains it well, but yeah.
Yeah, that helps. And in terms of, obviously you have a very solid and deep background in like research and learning about quantum computers and quantum physics. What are some other skills outside of that really technical space or the research space that someone might need in order to like go into this field?
Yeah, I would say actually, if you have knowledge of another field, that would be extremely useful, because a quantum computer is essentially a tool. So we need to apply it to something.
Yeah.
And I think one of the big problems, I wouldn't say problems, but challenges right now is, okay, what can we actually do with a quantum computer? Because, they do exist now, they're not perfect, but we want to figure out what could we apply this to, like in finance or in space or in logistics. And the thing is, people working on quantum computing, right, they don't have deep knowledge of these other fields. So it's hard for them to know what the problems are in this field to apply to. Of course, they can collaborate. So for example, IBM, who's working on quantum computing, collaborated with JP Morgan, who does finance, and they actually came up with, they collaborated on a paper in quantum finance. Wow. So that's an example. But so if you have knowledge of another field and like, oh, these are the problems in this field, here are hard computational problems, then that actually would be extremely useful for quantum computing, because then you could basically see if you could apply a quantum computer to solve those problems.
That's awesome. And I guess just to talk a little bit more about the skill sets needed, you can actually either work in the software space of quantum and also the hardware space, correct? Can you talk about the hardware just for a minute?
Yeah. So you're right. So there's the hardware and the software. So the hardware is obviously physically building the quantum computer. And there are actually different ways to build a quantum computer. So yeah, there's a whole bunch of terms that I could use.
Okay, what are like the
So
top three or top four ways of building a quantum
yeah.
computer?
So the top one is, well, so one of the most popular ones is superconductors. So you can use that. Another one is actually photons, which is basically light.
Right.
So you can
Yeah.
use light. Another one is trapped ions. So these are
Okay.
atoms with a net electric charge, and you can find them in a space. And there's also diamonds. So you can even use diamonds.
Oh, nice.
Yeah. I actually have a friend working on diamond quantum computing at Stanford, and he was like, oh, yeah, if you ever need some diamonds, just let me know. I was like, oh, that's pretty cool.
Okay, yeah, that's super cool.
Yeah.
So in terms of, people who are working in this field, you're from mixed, ethnicity, right? Why is it important to have diverse people working on such and like emerging technology, but such powerful technology, right? I
Yeah.
know we mentioned earlier that it's very valuable to work in a different field and bring that knowledge into working with quantum computers, but why is it like critically important for people with diverse backgrounds to be in the space as early as it is right now?
Yeah, I would say first of all is, there are just a lot of studies that show that diverse teams just lead to better solutions and better business. So I'd say, I think if we have more diverse teams, we'd actually be able to hopefully find new applications of quantum computing, especially since it's so early on. It's an emerging technology. There is so much like opportunity to influence the field. And so I just think the more different minds and backgrounds and people that come into this, the more progress we're able to make and really influence this technology. I'd say second reason, obviously, is because, we want to encourage the next generation.
Mm,
And quantum physics is kind of, it's really hard for our minds to wrap around because,
yeah.
we always thinking classically, but perhaps it's possible with the kids that we can, give them quantum games. Maybe they could gain more intuition for how quantum works. Anyway, so they will be the future generation who will really bring this technology, to do all of these amazing things we want to do. So we want to encourage as many of them as possible, and who are interested. So like me, I was interested in it, and it's sort of, I needed that spark, right? Like someone to tell me, oh, like here's this thing called quantum physics. So I think it's the same that if we have just more diverse people, we can encourage the future generation to get involved in it, and they can see someone, like them who's involved, and they can be excited to get involved in it too. And then I think the third thing is we need to start thinking about like the ethics of this technology, especially as it's emerging. I think obviously the focus right now is to actually build the technology because
Right.
it doesn't work 100%, and that is definitely the focus. But there is a problem. Is like, okay, we work so hard on this and we only focus on that, and then we get it, and then it it goes out into the world, and then it's like, oh wait, we forgot about the ethics of this.
Yeah.
And I think there's a lot of technology. AI, for example, is something where all these like problems started emerging. So I think obviously you can't foresee all of the problems, but we can definitely start thinking about it now. And I just think if you have more diverse teams, they're able to think about like all the ethics from different countries, different backgrounds, different people. So yeah, I think that's important.
Yeah, and I think, like you shared your story earlier on of just, going to a specific, I think either field trip and then like that spark of like, oh, physics, like what is this? And so I feel like the more we're able to expose emerging technologies to people of color, from people to people from different backgrounds and ethnicity and race, I think the better we can build a more quality, in terms, and I feel like you said with AI, like now we're just like, okay, there's a lot of bias in AI, but it's like that's because certain people are building the algorithms, and I definitely agree with everything you said about like diverse teams make better product. And so I hope that people who are listening feel encouraged and empowered to go into this field and are able to create amazing products. And so In terms of people listening and wanting to learn more about going to quantum, computing, the obvious way is obviously going to school for it. But what are some tips for those who are like, okay, this sounds super interesting. I want to learn more. How can I build a career path, pursuing or learning more about quantum computing?
Yeah, I would say, so the great thing about starting quantum computing now is that we actually do have quantum computing devices, and anyone in the world with internet access can essentially run something on a quantum computer. So in fact, when I got into quantum computing, this wasn't really possible. So I think that's something that should definitely be taken advantage of, is if you want to get involved in it. So there is this platform called the IBM Q Experience. If you Google it, you'll see this website pop up, and you can actually create an account.
Nice.
And then when you create an account, you can actually they have this interface where you can basically run programs on a real quantum computer that they have in one of their offices in New York or wherever. So I would recommend, first of all, I would probably recommend, if you know nothing about quantum computing, is sort of just learning the basics. So there are a bunch of online courses. That's obviously an advantage of today too, is there's so many online courses.
Yeah.
So for example, there is the Quantum Information Science course on edX by MIT. There is the brilliant.org course, which is in collaboration with Microsoft and Alphabet X. And you could even go textbook style if you want to. So one of the most popular textbooks in quantum computing is called Quantum Computation and Quantum Information by Michael Nielsen and Isaac Schwang. I should know it's a textbook, so it's a lot more in depth. But if you want something more in depth, you could do that. Or if you want something lighter, you can, there's actually a bunch of textbook books on Amazon. You can look quantum computing, and once you've sort of learned the basics, then I would recommend actually go do it. I'm a huge believer in learning by doing. So go to the IBM Q Experience. They have a bunch of tutorials, but actually go run some programs. If you can get involved in a project, then do that, and you'll just learn a lot more.
Awesome. Thank you for sharing those resources. I'll be sure to add them in the show notes so people know where to go. And so now we're going to switch gears and move into the lightning round, which is just 4 or 5 questions just to get to know a little bit more about you. So feel free to answer them in 6 or 7 words or less. Okay.
Okay.
All right. These are the easier questions, so no pressure. What is one of the biggest misconceptions about what you do?
The biggest misconception is that quantum computers do not exist and they do not work, but they do.
Okay. What is your favorite piece of technology right now?
It is Coda, Coda. You can basically build your own custom apps, spreadsheets, databases, and it's really has a lot of functionality. It's pretty cool.
Nice. What is your favorite time management trick?
I use a variation of the getting things done method.
Okay. I'm curious. Can you share more on that? I want to learn because I need to manage my time better.
Oh yeah, there's actually a whole book on it. So
okay, cool.
I don't know if I can explain the whole book, but it's basically the system. But basically, I assign all of my tasks to a specific day. So I have this kind of calendar. It's not even a calendar. I have this whole timeline thing where I put tasks according to days.
Okay.
Yeah, and it just
Okay. I'll look into it. I'll do my research. I'll learn by doing.
Yeah.
All right. So the next question: what's the best career advice you've ever received?
So I thought about this, and there's something that I've learned is planning is useful, but plans are useless.
Okay.
Yeah.
Interesting. I kind of like that. How would your parents describe what you do for a living?
So I actually had to ask my mom and dad, and they were very optimistic. So
okay.
my dad said, "Oh, researcher working on cutting edge technology."
Okay.
Which is nice of him. And my mom said impacting people's lives, which is very nice of her.
Oh, that's so cute. I love that.
Yeah.
What's something that brings you joy right now?
Almost every morning I go outside for a run in nature where there's no cars and I just stretch and I worship God, and it gives me joy almost every morning.
I love that.
Yeah.
Well, that's all the questions I have for you. And I'm sure that I've learned a lot from this episode, and I'm sure that a lot of people have done the same. And so if people want to learn more about you, what's the best way for them to find you online?
Oh, yeah. So I have a website, jessicapointing.com. So you can go to my website and there's like contact information there. Yeah.
Awesome. Well, thank you, Jessica, for joining me on the Techalog podcast. This has been an amazing episode. And if you're listening or watching and anything out of this episode jumped out to you, feel free to use the hashtag Techalog to share your questions or just your insights. And I'll catch you all on the next episode. Bye, everyone. Thank you, Jessica.
Thank you.